So here's a little motivation on rearranging formulas. Suppose I have P feet of fencing to use to fence in a rectangular garden for my vegetables. And I went ahead and drew a picture of that down here below that you can see. Let's put some pretty highlight on that. Here's my beautiful picture of my vegetable garden. Now, if it helps, always have a number in mind that P might be. So maybe you're thinking of a really big vegetable garden and you have something like 250 feet of fencing. If you have one number in mind, but you know that number could be different, that often helps when we're working with variables. So this fence that I'm going to use in my garden will form the perimeter, and it was rectangular. I was told that information in this problem. So as I go through the process of solving this problem and building that, I'll want to keep that in mind, that I have a rectangular garden and the fencing is for the perimeter. So I'm using that underlining property. I'm going to use the perimeter to see how large L is. For instance, if W is 15 and P is 70. So that might be a slightly smallish vegetable garden, but totally possible. So the perimeter should be the sum of the lengths of all sides of the garden. So you'll notice I made clear where my fence was here by drawing little red hatch marks around my rectangle. And P is the sum of the lengths of all the sides. So I'm adding, if we start over here on this left side, I'm adding that length L plus continue laying fence, the length W, plus I need the length along this side that is parallel to L because it's a rectangle. That side length would also be L. And then I have to go and do the last side here. That would be another W. So L plus W total, or 2L plus 2W. And if I apply the distributive property to make that a little bit tidier notation, just using fewer symbols, I can write that as 2 times the quantity L plus W. Notice this answer is not any bit better or worse than the one I had in the previous line. Both of these are fully acceptable versions of the formula. I have P equals 70. That's my P. And then I was also told what the width of my garden was going to be. So we could imagine that maybe it's going along some area in my yard where the widest that W could be is really 15. So now I can use that. I can plug those values into the formula and I can find the value of the length based on the data I know. You might say, why would I want to know that? Maybe I'm just trying to measure out where the garden goes. Or moving forward, maybe I actually want to know how much area is in my garden, so I have a sense of how I'm going to space out my plants. So if my garden does have 70 feet of fencing and therefore perimeter, and the width is 15, then I'm going to set up an equation like I have here on the low left, where I take the 70 and I replace it with P equals 2 times L plus W, but my W is 15. So then replacing and multiplying out, I get 70 equals 2L plus 30, 40 equals 2L, dividing by 2. In this case, I get that the length of my garden is 10. So I'm looking at a garden where there's 70 feet of fence to encase something that is 15 feet wide by 10 feet long. Now, what if I just want to adjust the values of P and W a lot? I go to the store and find out that 70 feet isn't actually a measure of how much fencing I can buy at a time. I'm going to have to change that. Or maybe I discover, oh, I'm not sure. Maybe I want W to be a little smaller. Now, if every time I change P or W, I have to go back to the original formula and plug those numbers in and solve, I'm being slightly inefficient. The point of rearranging formulas is to find a way to, if I know 2 values, can I get the third? And do it on the algebraic scale as if I knew what those numbers were, so that now I can just replace and get the value that I'm really seeking. So I'm going to show you that algebra. That's what I've done down here below. Actually, I'm going to erase it so that we do it from scratch together. We had the formula P equals 2 times L plus W. And I want to solve for L in our examples. So I'm going to start out by multiplying through by L. And the reason I'm choosing to do that first is just because I know the L part needs to be left on one side. And right now, L is trapped in an expression where it's all been multiplied by a number and there's a W added. It would not have to be my first choice. So if your first thought was, oh, maybe I should divide by 2, I'll show you that here on the right. So we'll do it both ways. So maybe your first choice actually, and looking at this equation, was to divide both sides by 2. We did that as our first step. We have P over 2 equals L plus W. And then to find out what L is, all I have to do is subtract that W quantity. So now subtract the width, no matter what it is. So P over 2 minus W equals L. And now, very quickly, I could give you a whole bunch of possible lengths for P and W. Bunch of different lengths for the total amount of fencing, as well as the width that I need in my garden to be, and you could very quickly tell me what L is. Another place where you could see this as being helpful is if you wanted to code a spreadsheet or use a computer to help you in your calculations by finding a formula that allows me to say, if I know these two values, what is the third? And setting it up on the symbol level, I can teach a computer to do that calculation and build like a whole table of different lengths until I find the one that says, hey, that's going to work best in my backyard. I like those lengths. So that's one way to solve this. We get L equals P over 2 minus W. If I use the other formula, let's see how it works differently. So if our first step had been to multiply through by 2, then I still want to get L, which is currently attached to a 2, and then there's other stuff added on. So my move here is to subtract the 2W because I need things that don't have L's in them at all to be on the other side of the equation. So subtracting 2W from both sides, on the left I get P minus 2W, and on the right, I get 2L. Now I'm going to divide both sides by 2. Divide by 2, divide by 2. And so my formula looks like this. P minus 2W all divided by 2 is equal to the value L. Take a moment and type in the chat or raise your hand. Why are these two expressions the same? How can I see that those two expressions for L are actually the same? This is the process I'm going to use every time when I'm searching for formulas. So if I have a formula that relates variables, I can use it to find other variables.